So welcome back, and next up is Franco from MCF88, and they are a long-time LoRaWAN product maker, and he's going to tell you all about their awesome devices. Enjoy his talk.
Hello to everybody, thanks for attending to this demo about LoRaWAN and ModBus sensor in the industry. I'm Franco Zampicinini from Enginko, and I'm from the R&D IoT department. This is the program of the demo. We start with the ModBus basics. We focus on the ModBus RTU settings, how to configure slaves, how to read or write registers. I'll show you some examples, and how to connect a ModBus sensor to TTN, and some tips and limitations of this technology. ModBus is open, royalty-free protocol with more than 40 years of life. Is a de facto standard, is very common, and it allows the connection of a master and several slaves. There are two versions, one with the serial interface, RS232 or RS485, and one for Ethernet. The ModBus RTU has one master and several slaves. The ModBus TCP is based on the client-server communication model. We focus on the ModBus RTU because it's the cheapest and the easiest to set up. It's differential single line balance, half duplex. That means there is only one channel for the transmission and for the receiving. There are at least one slave. There are two logic levels, 0 and 1, and additional 3-state level. The communication is very robust, it's noise tolerant because it's differential, and if well implemented, is very reliable. It's cheap to deploy. The cable is only a single pair of twisted wires and a ground wire. You can connect up to 32 devices on the same daisy chain. Since this is differential line, to avoid signal reflection, you have to use two termination resistance fitted at the beginning and the end of the main cable. If the data rate is low, or the cable is short, less than some tenth of meters, you can avoid to use the termination resistance. My suggestion is to use at least one termination resistance at the end of the line. If the data rate is high or the cable is long, you have to use the termination resistance to avoid data corruption. Use twisted pair cable because it's a differential, otherwise the benefit from a differential communication is lost. Better if the cable is shielded. If you use a shielded cable, you have to hurt the shield only at one point at the end of the main cable. With termination resistor, you have to use also bias resistors. The ModBus physical layer has two levels, 0 and 1, but since it is a half duplex, there is also a high impedance state that normally called 3-state level. If the ModBus is in 3-state and there aren't any polarization resistors, the voltage level will be 0 volt. For the ModBus, 0 volt is unknown. So the receiver doesn't know if the level is 0 or 1. As you can see in the picture, a value greater than 200 millivolts means 1. Voltage level less than minus 200 millivolts means 0. If the voltage level is in between these two values, is unknown. So with the use of the bias resistor in three-state condition, there will always be a well-known level on the input. On the market, you can find devices with determination resistors already implemented. Could be switchable, and also with the polarization resistors. The polarization resistors must be fitted in one point of the line, normally near the master. The data format of the ModBus RTU, each frame is formatted by 11 bits, so one start bit, 8 bits of data, one for parity, one for stop. The default is even parity. ModBus RTU needs a device address that is a unique 8-bit number that identifies the slave on the line, the function code for reading and writing, the number, the register number that identifies the register that master wants to read or write, the length of the register, the data, and the checksum. ModBus defines several function code. Since the ModBus register are associated with a function and an offset within that function, you will have to take into account the function and the register. So different register has different function. Some manufacturers use an absolute addressing already related to the function, but the standard addressing is relative. So you need the function and the offset of that function to access to the register. There are 4 types of registers. The coils are 1-bit register for outputs and can be read and written. Discrete inputs are 1-bit register for input, only readable. The input register are 16-bit register for input, only readable. And holding register that are the most universal 16-bit register, can be read and write, can be used for input, outputs, configuration data, and any requirement for holding data. This is an example of a configuration table where you can find the label of the register with a mnemonic label, the address of the slave, the function associated with that with the command, the relative address, the length of the register, in this case 4 bytes, the baud rate on the physical line, and the parity, in this case, is known. Here another slave with a different address, the same function, 3, that means reading, the relative address, the length of the register you are reading, and a different baud rate, a different parity, in this case is even. You can also write with function 6 or 16. 6 means write on single register. 16 means write on multiple registers. So here you can see that the data is different, has a different length between the single register and the multiple registers. Here some example of registers table. In this case we have an absolute register. Here we have a relative register, depend on the manufacturer. It is not always declared if the registers are relative or absolute, so you have to pay attention to this information when you configure the ModBus master. Here's some example of sensor, energy meters, 3-phase energy meter, 4-channel output, analog output, 8 analog input channel, 8 thermocouples input, and 16 output. So there are a lot of different sensors on the market because ModBus is a very common protocol and with a lot of advantages. So you have to choose the right sensor for your application, but it's quite easy to find on the market the sensor that you need. This is the power of the ModBus, the flexibility, because you can have the data in the way you prefer, depending on the master that you use. In this case, we will use a LoRaWAN master to read data from the field. The applications are, I can say, unlimited because since there are many masters, there are many applications, many slaves, there are many applications. So for the water quality in the pools, for the concrete temperature, for the level measurement, for the poultry, for the big industry, so for the energy monitoring, for gas metering. Here, an example using thermocouples to ModBus sensor and a ModBus to LoRaWAN interface. The DataXcel devices can read up to 4 thermocouples. The MCF88 interface is a Class C ModBus RTU master. Can read and write on time or on downlinks, and it can read up to 512 bytes for every reading. We use 2 probes, 2 K-type thermocouples connected to TTN. The first step is to configure the physical layer of the ModBus RTU, choosing the right baud rate, the right parity, the sending interval. This is our tool to configure the sensor. Here the graphs of the K-type thermocouple. We can see that the DataXcel device can read the K-type. The device uses an absolute addressing, so we have to take into account of the offset when we configure the master. And here the data on the console of the TTN. It's not easy to have the code for ModBus data, since it depends on the configuration that you write on the master. You have to know the register number, the length, so it's easier to decode the data on the application side. You have to know the configuration of the master to decode the data in the right way. For example, this is the uplink from our master. There are 3 bytes of 4 bytes of configuration that are specific from the sensor, the payload type, report ID, the frame number, the data length, and here the 6 registers that we had from the slave. So the configuration type, 4 K-type probes, the cold junction temperatures, and the 4 channels, 2 populated and 2 unconnected. You have to take into account the limitation of the radio transmission. So, for example, in the EU band, where you have a duty cycle limit of 1%, in this example, you can receive from 1 to 30 kilobytes, depending on the speed factor, for every hour. You must calculate the data amount related to the timing of the reading to be sure to are able to receive all the data that you read from the slaves. It's not easy to calculate because depend on the splitting factor, depend on the band that you are using, but is essential to do to avoid the loss of data. Here are some tips on ModBus, tips from my experience in the industrial field. ModBus is very robust, is reliable, is easy to implement, but it needs some attention to give the best, otherwise it could be a nightmare. First of all, use a twisted pair cable. Is a differential communication bus, so the twisted cable is mandatory to achieve the best immunity on the field. Check the polarity of the wires. You have the 50% of probability to connect in the wrong way. The 50% plus 1 usually, and different manufacturers use different names for the wires. A, B, D plus, D minus. Always place at least one termination resistor. Better two, depending on the baud rate, on the length, but at least one termination resistor at the end of the bus. And don't leave the termination resistor or resistors without polarization. Otherwise, it will be a mess, because only termination resistor make the communication very unstable, because when the communication is in the three-state situation, the data is unknown. Avoid the stubs, so you have to connect the devices as a daisy chain bus without stubs. Use a twisted pair cable. I already said. Okay. Please use twisted pair cable. Double check the addressing of the registers. Standard, absolute, offset, base 1, offset, base 2. These are the main troubles that you can meet during the use of ModBus Master, because most of them makes the bus running, but not always. So if you have a bus that sometimes runs, sometimes doesn't run, is the worst situation. So please remember this point. The rest is only software. Please note MCF88 now is Enginko. This year Enginko acquired RFTech from the vending market and MCF88 from the LoRaWAN market to give a best service for the customer. Same people, same product, nothing changed from your side. So don't care if you receive a sensor that from Enginko, they are still MCF88 sensors. Thank you for the attention. Thanks for your patience. Sorry for my English. If you need more information, write me or meet me at the booth, or write me an email to reserve a meeting in the next hour, next days, and thanks again. See you.